favorite YouTube class, Electronics class Tanzania. This is lesson 2. We'll start with the recap about lesson 1. In lesson 1, we learned about the application of electronics. We checked the definition of electronics as a branch of engineering which deals with electronics flows in the vacuum, semiconductors, or gas. And we see the application of electronics. There were about 6 applications, to mention a few. The first one was a rectification. Rectification is a process of converting AC to DC. DC has many applications, and among them is the charging of the battery. Another application of electronics was amplification. We have learned in the lesson 1. And the amplification also is the process of converting weak signals to much stronger signals. And the application of amplification, you can find it in a PA system and also in radios. Another application of electronics is the control. We learned that the control voltage is controlled in motors by using electronics devices. Also in refrigerators, voltage is controlled by electronics devices. Another application of electronics is in generation. Generation has to do with the oscillation. It's a conversion of DC to AC, and also has many applications. Another application of electronics devices is conversion of light into electricity, and this is called photoelectricity. And also there's many applications. And also another application of electronics is conversion of electricity into light. And this is applied in television and other systems. And also we learned about the atoms, and we've seen the atoms as nucleus is a central part, and neutrons, and also is surrounded by the path or the outer shells which have electrons, which is very useful in the transmission of electrons and electricity in general. Today we are in lesson 2 of Electronics class Tanzania, and we learn about Ohm's law and then diodes. We'll have just those 2 topics, Ohm's law and diode. Let's go. Ohm's law, by definition, Ohm's law is a relationship between first current, second voltage, third resistance. Very simple. Ohm's law is the relationship of those 2 items: current, voltage, and resistance. Now let's see the relationship of voltage, current, and resistance in terms of algebra. We'll start with a simple circuit with 1 resistance. We have our battery here as a power source. Then we have our resistor here, and this is a circuit. We learned in lesson 1 that a circuit is a closed loop of electricity flow. This is a circuit. So it's a 12-volt battery. This is positive. This is a 4 ohms resistance. The unit of the resistance is ohms. In the algebra terms, the Ohm's law is the relationship of voltage equal to current and resistance in mathematical form. So in our circuit, when we want to find a current, the current flow this way. The current unit is I, and it stands in ampere. So if we want to know how much current is flowing in this circuit, we have our voltage here, that's 12 volts. We have our resistance here is 4 ohms. It's 4. Then when we want to know how much current is flowing, then we divide by 4. And then current here is equal to 12. 12 by 4 is 3. And it's ampere, amps. So 3 amps will flow in this circuit. Let's see another circuit which have 3 resistances. We have our source here, as always. We can put here 60 volts, much bigger voltage. And in lesson 1, we learned that the voltage is a push or pressure which forces the current to flow. Then we'll have our series circuit, the first resistor here, the second resistor here, and the third resistor here. This is this positive, negative. This is a series circuit, R1, R2, R3. And we can have values here, can be 3 ohms, can be 4 ohms, can be 5 ohms. Then we have to find a current. How much current will flow in this series circuit? The first and foremost, we have to find a total resistance in this circuit. So this is like a big resistor. The total resistance here is equal to summation of R1 plus R2 plus R3. So the summation here is 3 plus 4 plus 5 is equal to 12 ohms. This is the total resistance. So back to Ohm's law. It's the relationship of voltage and current and resistance. This is our Ohm's law. We use Ohm's law to find the current. So current equals to voltage over resistance. We have our voltage 60 volts. This is 60 volts. We divide by resistance, a total resistance which is 12. So we have 5 amps. Divide 60 by 12, we have 5 amps. So 5 amps, 5A, will be flowing in this series circuit. Yeah, we have seen a relation of Ohm's law in a series circuit. This is our series circuit. We have 60 voltage here, plus minus, and the current flows from high potential to low potential side. This is current ampere. We have our 3 ohms here, we have our 4 ohms here, we have our 5 ohms here. Current flow in this direction. Then let's see the relation of Ohm's law in a parallel circuit. As usual, we have our source here, a battery with 60 volts, and we have this parallel circuit. We have 3 resistors which are in parallel. R1, R2, R3. This is the 3 ohms, 4 ohms, and this is 5 ohms. Then we want to know what's the current flows in this branch, what's current flow in this branch, what current flow in this branch. This will be I1, this will be I2, that's current, this will be I3, current 3. In Ohm's law, In a parallel circuit, the voltage is the same, will be the same. This 60 volt, when you take a voltmeter, you will find 60 ohms here also. Here also will be 60 ohms. 60 volts. This is the voltage, 60 volts. So you'll find here also 60 volts. Here also 60 volts. Here also 60 volts. In a parallel circuit, the voltage is constant. So, back to Ohm's law. Voltage is equal to IR. The current here in this first branch, in I1, the current will be voltage over resistance. We have our 60 volts here over R. The R is 3. So we have 20 ampere. So 20 ampere will flow here. 20 amps will flow in this branch. Let's see I2. The formula is the same, Ohm's law. The relation is the same, voltage over R. As I said, in a parallel circuit, the voltage is the same in each branch. So we have our 60 volts there, divided by our resistance, which is 4. So 60 by 4 will get some, will be 1 point. We'll take a calculator and then we'll have some 1 point something here. When we take 60 divided by 4, it will be let's count 4. 64 is 2, 25. You see, it is 15. So you'll have a 15 ampere. 15 ampere flows in this branch. The third branch is also the same formula. I3 is equal to voltage over resistance. 60 will be over 5. Also, you have 12 ampere. So 12 ampere will also flow in this branch. According to Kirchhoff's law, Kirchhoff's law deals with the relation between Kirchhoff is a law which says that a current flows in a node is equal to the summation of the branches which flow outside the node, or the summation of the current in the node is 0. So, for instance, let's say this is our A1 and A2. Yeah, this is the node. Let's take first node and let's see Kirchhoff's law. So the current in this branch is 20, and we have to find a total current, the current which flows here. Total current. We have to find a current which is flowing here. Total current. This one we can find it by finding a total resistance. So the total resistance in a parallel circuit is equal to, total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So here we have 1 over 3 plus 1 over 4. We have 1 over 5. So this will get our total resistance. Okay, guys, let's continue Ohm's law in a parallel circuit. This is a parallel circuit. We have our resistors here. we have 3 resistors. This is R1, R2, R2, this R2, and R3. These 3 ohms, 4 ohms, and 5 ohms. Our 60-volt battery here, and positive, negative, our current will flow in this direction. This will be I1, current 1, this will be current 2, and this will be current 3. This will be total current. And according to Kirchhoff's current law, says the total current here will be summation of the current here and current here. So, from Ohm's law, the voltage which has a relationship between current and resistance. So to find the current here in this I1 is equal to voltage over resistance, which is equal to 60 over resistance, which is 3. In a parallel circuit, the voltage is the same in each branch. So our current here is equal to 60 over 3 is equal to 20. Our current here is 20 ampere. The unit of current is ampere, and the unit we write it as A. Current 2, same formula, V is equal to IR. We have our voltage here 60 over our resistance, which is 4, and then we have 15 here, 15 ampere. Also I3 is equal to 60 voltage, is the same voltage across the parallel circuit, over 5, we have 12 ampere here. So according to Kirchhoff's current law, Kirchhoff current law, that the current flowing in a node, this is a node, is equal to the current flows away from it. So that the current, total current, will be I1 plus I2 plus I3. So the total current is equal to 20 plus 15 plus 12, which is equal to 15 and 12, we have 27, and here 27, we have 47 ampere. This is our total current. Our total current in this circuit. By using the relation between current and the voltage, we can have a total resistance here using Ohm's law, which is VIR, and equal to R is equal to V over I, and the V is 60 over I is 47. This is ohms. This is our total resistance. And you've seen here that the resistance is small because in a parallel circuit it tends to divide the resistance. The resistance is being reduced in a parallel circuit. So in this relation we have seen here, I1 is 20 because the resistance is small, I2 is 15 because the resistance is much bigger, and I3 is much smaller because we have increased the resistance. So if the voltage maintains the same, when you increase the current, the resistance should go down. So current is inversely proportional to, if we increase the current, the resistance should go down, and the voltage should remain constant. Also, we have seen here the voltage is constant because the circuit is parallel. We are continuing with our lesson 2 in Electronics class Tanzania, your YouTube class. we are going to learn about diode. Diode. Diode is a very useful device in electronics. Very, very useful. And the diode is a, by definition, is a semiconductor. Semiconductor, which allow current to flow in one direction. This is the definition of diode. Diode is a semiconductor which allows the current to flow in one direction. Of course, it can flow also in a reverse direction, but you have to apply very high voltage. But in practice, it flows in one direction and it has application for that properties. The symbol of the diode is this one. This is positive, this is negative. This is positive, this is negative. This is the symbol of the diode. The electrons are flowing from high potential to low potential. So the current will flow in this, in this direction. And if this is the right application. But if the current flows in this opposite direction, this is not a correct application. The diode is made of two materials, P and N. This is a silicon diode which has been doped with P material, and also it dopes also with N materials. So you put together P and N, you get the diode. And this side is positive, this side is negative. And the positive side is called anode. This is anode. And the negative one, this one is called cathode. This is anode and this is cathode. So the current will flow in this direction. Of course, the electrons are flowing in the opposite direction, but the current will flow from positive to negative. And if we put it this way, this is low potential, and this is high potential, 6 volts, let's say, we have 6 volts here. Here high potential, this is low potential. The current will flow in this way through the diode. The diode will be on. We say the diode is on. Also, if you have here another diode with low potential, this is a low potential, and here we have positive 8. This is high potential, but here is N, and if this is N and this is P, here the current will not flow because it is being reversed. But also you can have another scenario which you have a negative, let's say you have negative 7 here voltage, and here you have your diode. If your diode here, this is zero potential, but negative is much lower than 0 potential. It's much lower. So you have your P, your N. This will be on. This will conduct because the current will flow in this direction. because here we have much larger potential than here. This will be on. So let's see the graph. The graph of a diode, which put the property of the diode together. We can have a graph here, which is, this is current, forward current, and this is forward voltage. Here you have a reverse current, and here you have a reverse voltage. This is forward, this is a reverse. In operation, a diode will conduct when it is in a zero, when you apply 0.7 volts here, the diode will start conducting. So if it's in a graph, it will be like this one, and in a reverse direction, here let's say it will be minus 100 volts. This is called knee voltage. 0.7 is called knee voltage. Let's see diode in a circuit. We have our battery here, a 12 volt battery, positive, negative. This is a circuit. We have our resistor here, and we have our diode here. This is a diode in a circuit. Let's say we have a 4 ohms here resistor, and current will flow this way because it's a high potential. The current will flow in this direction. The voltage here we've seen is 0.7, which will allow the diode to conduct. So if we want to know how much voltage is in here, by using the Kirchhoff's voltage law, we'll find a voltage here, which will be total voltage, which is 12, equals to voltage in a resistor plus voltage in a resistor plus voltage in a diode. So we have voltage in a diode, which is 0.7, and now 0.7 plus VR we are finding here is equal to 12. So VR, voltage in a resistor, is equal to 12 minus 0.7, which will be 11.3 volts. So here will be 11.3 volts. This is our voltage in a resistor. And so if we want to know the current which will flow here, we come again to the Ohm's law. Ohm's law is the relation between I, current, and resistance. The unit of voltage is volts, and the unit of current is ampere, and the unit of resistance is ohms, which is omega. So we want to know the current. So the current here is equal to voltage of R, which is voltage is 12, and we have to have a total resistance. So we have to find the resistance here in a diode. In a series circuit, the current is the same. The current flows here will be the same with the current flows here. Current flows in the resistor is the same with the current flows in a diode. So we have to find a current here in a resistor. By a relation of V is equal to IR, the voltage here we have is 11.3. The resistor we have here is 4. That's the resistance. So our current I is equal to 11.3 over 4. So by using calculator, we'll see how much is the current. 11.3 divided by 4 is equal to 2.824 ampere, which is amp, which will flow here, and also the same current will flow here, the same current will flow here, because this is total current. The current in a series circuit is the same. So we have to find the power dissipated here in resistor, also the power dissipated here in a diode. The formula of the power is equal to VI, which is equal to watt. The watt is the unit of the power. So the power dissipated in the diode will be voltage. Our voltage is 0.7, and our current is 2.824, which will be equal to, by using calculator, we'll see how much power will be dissipated in a diode. So 0.7 times 2.824 is equal to 1.97 watt. So this is the power which will be dissipated here in the diode. Also, power which will be dissipated in the resistor is equal to the same formula we are using. The voltage is 11.3 times current is the same, because it is a series circuit. The current is the same in the series circuit. By using calculator, we'll see how much power will be dissipated in a resistor, which is 11.3 times 2.824. So we'll have a power here is 31.9 watt. This is the power which will be dissipated here in the resistor. So in practice, the diode will conduct when the voltage is 0.7, and it will be from high potential to a lower potential. So this is a simple circuit, which is a resistor and a diode. We come in lesson 3 to a bit complex circuit, which will have many resistors and diodes, and we'll see how we can see the relation between current, voltage, and resistance. In our today's lesson 2 of Electronics class Tanzania, we have seen Ohm's law, and which is a relationship between voltage, current, and the resistance. And we've seen it that when the voltage is constant, when you increase the current, the resistance should be inversely proportional. The resistance should be small, then the current will be high. And if you increase the resistance, then the current will be low if the voltage is kept constant. That's Ohm's law, the relation between voltage, current, and resistance. Or in algebra, simple algebra is a mathematical application of current times voltage, times resistance, you have voltage. Also, we have learned about diodes. Diode is a very, very important device in electronics. And the diode is semiconductor materials which allows the current to flow in only one direction. But of course, it can flow in the reverse direction, but with high voltage, and this is not practical. And the voltage which make the diode to flow is 0.7 volts, which makes the diode to flow, and this is flowing in one direction. And this is main application in electronics. And in the lesson 3, we'll learn much about diode, because diode is, as I said, is a silicon material which is been doped with the P property material and the N property materials. And the P is positive and N is a negative, which is anode and cathode. And in lesson 3, we'll learn more about diode, and also we'll end up on transistors. We'll learn about transistors, which is an electronic switch, very fast switch and very useful in modern electronics. So don't forget to watch lesson 3 which will be about transistors and some simple circuit with small algebra in Electronics class Tanzania with your coach, Engineer Herini Mhina. Don't forget to subscribe, like, and comment in Electronics class Tanzania, your YouTube class, which brings you a lot about electronics issues. Thank you for watching.